What are arithmetic sequences? If we were to look at the sequence of numbers, we have a 2, then a 7, then a 12, then a 17. Now the 7 is obtained by adding a 5 to the 2, and the 12 is obtained by adding a 5 to the 7, and a 17 is obtained by adding a 5 to the 12. Now that is an arithmetic sequence by definition. When we are adding the same constant to move from one term to the next one in the sequence, we have an arithmetic sequence. And the 2 we have here defines the first term of the arithmetic sequence, and the constant we're adding, which in our case is 5, defines the common difference of the arithmetic sequence. Now, what is the general term of an arithmetic sequence? So, given the sequence of numbers, which we define by U1, U2, U3, U4, etc., which represent the first, second, third, and fourth term of the arithmetic sequence, and the pattern continues. Common difference of the arithmetic sequence we will define by D, and the first term of the arithmetic sequence is given as U1. Now the second term of the arithmetic sequence, which in our case is U2, then U2 is obtained by adding the common difference to the first term. So U2 is U1 plus D. And D, we can look at it as if it's 1 times D. The third term is U3 equal to U2 plus D. So to obtain the third term, we add the common difference to the second term of the sequence. We already obtained that U2 is U1 plus D. Now adding D and D, we obtain U1 plus 2D. Similarly, the fourth term of the arithmetic sequence is obtained by adding the common difference to the third term. So U4 is U3 plus D. And we already obtained that U3 is U1 plus 2D. Adding 2D and D, we obtain U4 equals to U1 plus 3D. And this pattern continues. Now looking back at the pattern, I noticed that for the second term, when n is equals to 2, D was multiplied by 1 which is 2 minus 1. For the third term, when n is equals to 3, D is multiplied by 2, which is 3 minus 1. While for the fourth term of the sequence, when n is equals to 4, D is multiplied by 3, which is 4 minus 1. So we can in fact see the pattern here. So to generalize into the general term, in order to determine the nth term of the sequence defined by un, then we have the first term plus the common difference multiplied by n minus 1. Let's put this into an example. Given the sequence 14, 11, 8, 5, and so on. Now we notice that this consists of an arithmetic sequence with a common difference equals to -3. As to move from one term to the next one in the sequence, we subtract 3. Now the common difference is then defined by D equals to -3 for the sequence, while the first term of the sequence is in fact 14, which we will denote by U1. Suppose I need to find the 12th term in the sequence, which will be defined by U12, since the first term is defined by U1. Going back to the general term of the sequence, which was defined by Un equals to U1 plus n minus 1 times D. Since I aim to find the 12th term defined by U12, then I set n equals to 12. And the first term U1 is 14, so I replace U1 by 14, and D being equals to -3, I replace D by -3. Then U12 in that case is equals to 19. So the 12th term of this arithmetic sequence is in fact equals to 19. So how can we generalize the general term of an arithmetic sequence further, and in what sense? Looking at this arithmetic sequence with the first term u1 and common difference d. Now the general term of the arithmetic sequence as we derived it is un equals to u1 plus n minus 1d. So in order to find this nth term, I need the first term and the common difference of the sequence. However, if I aim to determine the nth term of the sequence un using a term of the sequence other than u1, let's just call it um, then in that case, since I replaced in the general term u1 by then the factor multiplying d, which is n minus 1, is replaced by n minus m. So in that case, you can consider as if 1 is replaced by m, considering that m is smaller than n. Now let's just put this into an example here. Given an arithmetic sequence where the sixth term is 4, and its common difference is d equals to 6. And suppose I aim to determine the 15th term, u15. Now over here, as you notice, we are not given u1, the first term. We can always find it. But however, since I'm given the sixth term, I could use the general form of the general term of the arithmetic sequence in order to determine u15 immediately from u6. So un is in fact equals to um plus n minus m times d. Now, the bigger index, which in this case is 15, is equals to m. So n is in fact here equals to 15. The smaller index, which in our case is 6, that is in fact equals to m. So m in our case is equals to 6. So first 15 minus 6 can be replaced by a 9. And then, since u6 is 4 and d, the common difference, is 6, by making the proper substitutions, we obtain u15 equals to 4 plus 9 times 6, which is equal to 58. So I was able to find the 15th term of the arithmetic sequence by using the 6th term instead of the first.